Hello there, are we live? Hello there, are we live? Okay, we seem to be live. Yeah, so long time no stream. Been busy for a couple of months actually. But yeah, I decided to, well, not decided, I want to get back into that streaming stuff. But I decided to do a little warm-up session, and I hope to actually do something quickly today, because I found this nice little effect that you can do with pixels and stuff using canvas, and I wanted to see how I can do this in WASM using Rust, essentially. So I highly recommend this channel. Guy has some nice tutorial for JavaScript. So if anybody is interested, have a look. But I'm not really interested in the actual effect and the JavaScript part of it, just in the WASM stuff and how we can actually start playing with canvas just using Rust. So I basically took my stupid web page and I ported it to U. I ported it to Rust using U. U is this web framework that's very similar, like the React or the Vue.js frameworks from the JavaScript world, and I really enjoy using it, to be honest. And the reason why I ported it, originally it was just a static site generated using Zola, which is a Rust based static site generator, but I plan to do some more advanced stuff with this website, stuff that I wouldn't be able to do using just a static site generation. So I decided to rewrite it so that I have full control over what's going on the page, and I did it using U. So I should have this stuff actually running locally. Yeah, there it is. So this is the web page. That's the stuff. So I'm not sure how interesting would it be to go over the stuff, but basically you allow oh Jesus, that's going to be massive. The U framework allows you to basically create a bunch of components that you can use to assemble the web page. So if you're familiar with React or Vue.js, I don't know, I'm completely unfamiliar with Angular, so I don't know if there's anything in common with this. But yeah, if you know React or Vue.js, you should really be comfortable using U, because the principle is exactly the same. Let's do it like that. Okay, so I haven't looked at this in a while, so let me just get up to speed with this myself. Oh yeah, so basically, yeah. So we have the router functionality from here. We implement a couple of component traits, and that's it. And basically the U does the rest for us, which is basically just generating the entire WebAssembly stuff. I think we go through this while I start implementing this effect, to be honest, so let's maybe not waste any time. The only gotcha here is that I'm going with the master branch of the U for reasons. One of the reasons is that the U has this concept of where is it? Ah yeah, they don't have them here. We need to go towards the latest documentation. They have those function components which are like pure components, so I just wanted to try it out, so that's why I went with the master version. So all of this is going to be released in the latest version, but basically what's currently in the repo is just the version 18. And one of the other changes is in the upcoming release is that they remove all of the services. So basically they had a bunch of services that, well, you came with a bunch of services like the console functionality and the fetch functionality. In the upcoming release, all of this is going to be released. So basically if you want to make a fetch request, you need to go and use the WebSys directly, or any other crate that you might want to use for this. But basically WebSys allows you to create the requests for fetching data, and that's what I'm actually using right now for fetching the posts. So basically I'm composing the request using the WebSys stuff. So yeah, so basically that's what I want to start doing now, is just go and have a look if I can replicate this effect using just WebSys. And the reason why I want to stream this is because there's going to be probably some gotchas and issues that I might encounter, because while the WebSys is good, the whole, where is it? This whole project is actually supported by the Rust core team, as far as I understand. So it has a full Rust backing, but you know, that there are some issues here and there with the full replication of the JavaScript ecosystem in Rust. But yeah, as far as I'm following it a little bit, so it seems that they're doing a good job in managing to port the JavaScript functionality into Rust. Okay, so I just want to think a little bit how I want to do this, and maybe just hold on, I just want to catch up. Where am I currently with this stuff? Where's my web page? Here. I actually did a little blog post ages ago about you, but it changed quite a bit since then, so that's probably need to be updated as well. Yeah, so let me just have a little think how I want to do this with effects. So the view revolves around the components essentially, as you can see in here. So you just create a struct and you need to implement the U traits on it with a bunch of methods. And by implementing those methods, you basically give you pointers how the page should be rendered at any given time. So I think we're just going to start from creating the struct. We call it particle effect, maybe for starters. So that's going to be our component. We definitely going to need a particle, and I think that's it for the time being. So now we need to use the use stuff like that, and we don't have auto completion, and that's because we need to add it to the mode components mode. Yeah. So, how it affects effects. Yeah. Plural. Okay, dokie. So now here we should have the auto completion going on. Some errors. Yeah, that doesn't matter. I'll look at it later. Okay, so the particle. So we will need to. The particle, we need to be able to create it. We'll think about that later. We will need to be able to update it, because that's essentially we're going to get into the realm of you know, like graphics rendering essentially. So we will need to be able to update the particle, and if we're going to be updating it, it's going to be mutable self that we will need to pass into it. We're going to need to have a way of rendering it. Probably, well, if we're just rendering, let's see if we can do it like that. Okay, and then okay, and right now then let's focus on see how we can actually create a component which will give us this effect. So for that we will need to implement the component trait that comes from you for our particle effect component. So now we just need to implement this bunch of methods that comes with this trait. So first is the create. You preload. Okay. There. The Rust analyzer didn't see the stuff. So actually we need a type. So the type, it's the associated types with the component traits. So one of them is message. So I think we don't have any message for now, and type the properties. Like we probably will need to have some properties. What we will need, we'll probably need like width, height, number of particles, stuff like that. Okay, we'll think about this later. And we need the create function. So this is one of the main differences in that master branch version from the current one. Here they basically lump it all together, the parameters that they were passing in previously. So like properties, link, which allows you to which allows components to communicate with one another. Right now, all of this is lumped into context struct that they're passing into this. So I don't know if I can show it here. Getting started, examples. Okay, so all of the examples, they're actually looks like they're up to date. Are they? Project setup. Yeah, build the sample up. Yeah, so that's the old way of doing this, like in the version 18 that's currently in the crate repository, in the crates.ie. But the master branch and the future release is going to be this. So since we like to live dangerously, we're just going with the master branch. So yeah, so create. So right now we're just returning the particle effect, or yeah, particle effect. We need the update function. So right now it's going to be just false. I just want to build the skeleton. I don't think there is there was an update, so then there is a view method with again just the context, and that's supposed to return the HTML. Okay, so are we compiling? Should be good to go. Yes. Okie dokie, so we just need to be able to return a raw canvas in here. But normally we would make some modification, you know, as a result of you know, in an event handler or something like that. So as a result of a click, we would normally just react to that click by some sort of message, which we would specify in here. In the update method, we would make a match on that message, and depending what the message is, we would, for example, make some modifications to the DOM and return true. So then if the update methods return true, the U would basically re-render the entire page. But in this case, we want to animate stuff. So we not going to be doing this using the update method. We will going to be redrawing stuff using the canvas itself, at least in theory. So in order to do this, we need to be able to modify the canvas outside of the normal component lifecycle. So in this case, we can use something that's called a reference to the node, to the HTML node. Yeah. So in order to do this, we need to be able to keep that reference to that node within our particle struct. So for that, we need to be, so for that our struct, our component struct needs to be able to keep the reference to the node. So we're just gonna call this canvas, and that canvas, it's going to be the node ref. So what else we might want to store in there? So it's definitely going to be a node ref and probably the particles that we're going to generate. Particles, yeah, so that's going to be a vector of particles. Okay, and in here, in that case, we need to get the reference to that canvas, and we need to clone it. And canvas requires the closed tab. The HTML macro, it actually enforces heavily the soundness of the HTML syntax. So basically, any issues with the missing HTML tags and stuff like that will result in the compilation error. Okay, so what's going on here? So because we added this stuff here, we need to fix. Oops. So let's make this be more rusty. And we want the canvas to be node ref default, and our particles okay, are we good for the time being? Okie dokie. So what else do we want? Should we focus on the particles? Yeah, I guess so. So we need to be able to create a bunch of them. We need to be able to create a bunch of them. Okay. So yeah, so let's have a look at the particles in that case. So what particle might need? So it will need a position. Like that. What it will need? Probably size, because that's going to be used for drawing. 32 size. It will need the what is it? The velocity. Like that. So then that means that we will need to create a bunch of random values. So the particles are going to be flowing from top to the bottom, just like the example in here. So we will need okay, so here we're probably gonna need some random generation stuff. So I think that's the problem, because I don't know if the random generators work in in the WASM context, because it's basically WASM is like embedded, so there's no std libraries in there. So let's have a look. So we need this. And there's going to be probably some feature that needs to be enabled. Release, blah blah. Core features. STD. WASM support. The WASM target, blah blah blah. It's not automatically supported. Or add a dependency get random with the JS feature. And that's unfortunately what we're using. See get random WebAssembly support. So you just need to enable, yeah, with the GS, okay. But what does it mean? Like add it directly with this? So this either use a different target such as or add a direct or add. Okay, I think we need to add this in that case. Let's have a look. Ah, yeah, we need to fix this. So rand threaded RNG, I think it was. Yeah. So what does it mean? So X. So we want the particle to be generated somewhere on the so horizontally in random places, but started at the top of the canvas. Okay, so let RNG equals RNG. I'm not sure if that's unwrappable or not. So RNG range. So we went from 0 to yeah. We want it to be as wide as the canvas. So let's do it like, actually no, that's going to be stupid. Okay, let's do it correctly. So canvas width. So canvas width, it's going to be U32 for the time being. That, and then let y. We want it always to start at the top, and then let size again random. Again range. So from 0 to what's the proper size? Maybe from 1 to 2, I guess. I don't know. And what else? The velocity. So generate the range. So for velocity, I don't know, 0, 2, 1. Oh, so in that case, velocity, we're talking about a float. In that case, yeah. So more like that. Okay, so x, y, size, and velocity. No, what have I done here? That's not here. That's here. There. We're building. So that means we need to be able to pass the canvas. Canvas was mutable. Else. Is that okay? Yeah. Okie dokie. So in here in update, we on every call of the update method in here, we will just take the self y equals, we will just increment this for the time being. Later we will change that depending on the speed and the movement and stuff like that. So for the time being, we just want to make sure that it's fine. And then we want to be able to restart it back from the bottom. So what is it? If the self y is larger than the canvas width, canvas height. Yeah, so if it's okay, so that means it's going to be, so we need to store the height, canvas width, and canvas height C32 as well. Is there something on the chat? Okay, so canvas width, canvas height. Okay, so we need to take both of those as well. Not sure if that's the best way to do this, but we'll see for the time being. Okay, so that's going to be the self. Boom. So if it's larger, we're just gonna restart it back at the point 0. Y is 0. There. Yeah. We. Okay. Now we're going to be rendering it. So to render it, we need the canvas. Okay. So we need to have a look at what is available in here in terms of the canvas API. So canvas. Okay, so this and this is what we're going to be needing. So then basically we need to grab the context of the canvas HTML element, which is the raw element that we have a reference to in our component. So when we get the context, we will get the object which we will need to cast into this. No, where is it? Into this, yes. Okay. So this is basically straight away you can see how Rust is a little bit more verbose as opposed to what you could do in Java. So how can we do this? So in here, okay, so I see that right away that's going to be needed. So hold on. We will need the properties anyway. So we need a public struct called let's call it particle props, and we will need the width, which is u32, and we're going to need height, which is this, and we need to derive. We will need to derive the properties, and which comes from the U framework, and it's probably gonna have to be cloned as well. And since these are our properties, we need to tell you that this is what we're using for our properties. Particle props. So basically we will be able to access it from our context now. What's going on here? Oh yes, it requires also the what's it? Partial equal. Yeah. So now if we want to access the properties, we can do it. Let's say our props. So let's say our height, for example, would be context.props function, and then height. That should compile. Yes. But we don't need this for the time being. So maybe let's mount our component. So should I create a new web? Okay, I'm gonna go lazy and I'm not gonna create a new page for it, but I'm just gonna stick it in my silly little about page. So we're just gonna stick it somewhere here. So basically we just need to import our new particle component. So where was this? Components effects. I think we will need the particle props. And we will need the particle effect. There it is. Oh yes, we don't. Needs to be public. Is this okay? Yeah. Okay, so we should at least be able to see it in here somewhere. Header, no main. Oh no, I'm being silly because we need to. Okay, let's add it just here, like animals. Particle effect. And because we specified those particle props, and they're not optional, I think that should give us a compilation error that we are missing our properties. Blah 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 blah, missing required prop height. There it is. So what is it? Our height is going to be, let's say, 500, and the width is going to be 500. So I think now at least we should be able to see it rendered on the page. What is it? So now if we reload, mount this, there it is, that's our canvas. Okay, progress. So that's essentially how you create a component. Okay, so now we're not putting in our dimensions in here. So the width is not like that, it's like that. So again, context props dot width and height equals. Let's just like that. What does it want from me? That's because, oh yes, because we passed it in as an integers. So we can either just simply do it like this, or we can run a toString on our canvas element. Oh yes, no, actually I was wrong. Well, I was kind of right, but that's because we specified this as the U32s on our props. To string. Okay, this. So with our height, blah blah blah. Okay, so now we need to be able to render our particle effect. So for that, we're just going to simply import our particle effect, and we will specify a method called render. And in here, so in here, what we need to do is we won't be returning anything because we will simply going to be modifying the our canvas in here. So we need to basically, this is just a raw reference to our HTML element. So what we need to be able to do is just to grab it as the actual canvas element. Let's cast it into the canvas element, and that's unwrap. And so we can either specify the type in here, or we could just simply specify the type in here, and that's going to be HTML. No, that's going to be canvas element. And from there, we need to be able to grab the context. So canvas dot, that was just get context, was it? Okay, we have too much stuff here. So canvas, so get context, and the context ID as well, which I think for this is just 2D. So canvas get context, and it's 2D. And what was it? Unwrap. Get context, that give us result and option. Okay, so unwrap and unwrap, and then we just need to cast it, because this is one of the kind of weird things. Well, not weird, like once you know it, you know it. You get you basically get like a Rust representation of the JavaScript object. So once you have this, you actually need to I think it's cast. No, it's into. That returns the actual object casted into what you want exactly, which is this object called canvas rendering context 2D. Rendering context 2D, something like that. And that's a mouthful. find canvas element. Should be there. Oh yeah, yes. Basically, almost every HTML tag available, or almost every HTML object in WebSys is hidden behind a feature. So you have to list every feature that you use, every tag that you want to use. You have to list it in your cargo terminal. So we are using the HTML canvas element, and we're using the canvas rendering context. Is this also the feature? I forgot. Yes, canvas rendering context, canvas. Yeah, so we need to list both. Okay. So this is basically what I was saying with using the WebSys in Rust. It's not as easygoing as JavaScript is, because this strict types enforcement. Yeah. So essentially here, now that we have the context, we can start drawing with in the canvas itself. So, like, if you're familiar with the Canvas API, you should be able to just now start drawing stuff. So basically, let's just start it easy, and let's see if we can draw those particles like raining in the canvas. So let's fill the we need to fill the element that we're going to be drawing right now. So that's going to be those particles. So we need to set up a style of those. Like, I'm not the greatest in the Canvas API, but I did a couple of examples on the using just a JavaScript. So and in here, like normally in JavaScript, here you just basically specify the color, like white or the raw RGB value. But with Rust, because of the translation that it has to do between the Rust type and the JavaScript, in here we need to specify the JS value. So let's just, I'm not sure if black is like that. And then we need to be able to just fill the rectangle, and let's have a look at the parameters. So X, Y, width and height here. So we just want to fill the entire canvas. And oh yeah, so in here we need to be able to pass in the canvas. Well, no, exactly. We have the canvas, right? So actually, canvas itself, yeah, it gives us the height and the width. Okay, so you don't need to pass in anything. So canvas dot quit and canvas dot hide. Okay. Let's see how we're getting on. Not found this canvas rendering context. Yeah. This we need the canvas rendering context. And we need the HTML element as well. Yeah. HTML canvas. Oh man. Okay, so here we're getting into the stuff. Expected JSON, yeah, okay, so what's going on here? So that needs to be expected found. So as F64, as F64. What was the problem with this? That's just expects the reference, it's fine. Is that all? There was something here as well. Use. Okay, so, like that's the Rust thing. We need to be able to, in order to use the specific trait implemented on the object, you need to have that trait in scope. What was it? JS? No. What was that? That's not. It's coming from the wasn't binned again. JS cast here. JS cast. Okay. Check. Okay, so just a bunch of warnings. Okay. So let's see what we have here now. Okay, so definitely there's something here because it moved the stuff down. Okay, but nothing visible yet. Oh, is it? Yeah, because we just can see it. What was it? The I'm not sure if that's allowed. What was it, like RGB? Something like this. Let's see if we can display. Let's see if we can display the particles actually. Yeah, okay, let's create a bunch of articles, or particles even, and we'll see how we're getting on. Okie dokie. So yeah, we need to generate a couple of particles, and we need to render those. Okay, so actually, so this is one of the other things. So we need to be able to display them. So we will be keeping the rendering context in our component. So we will have access to this, so we can just pass it into our rendering method. So let's just the canvas context, and that's just going to be the reference to our rendering context. And in here, so how do we, what was the steps in canvas? That was something like, yeah, this begin path. So context dot begin path, and we fill the style. Next, style. So we have a black. We should have a black background. Style, and again we need to pass in the JavaScript object. So the JS value from string and RGB and like 255 forward, and then we can just draw the arc, which will just create the our particle, which is essentially just a circle. And here, what do we have? Arc. There's a bunch of parameters for this. Oh, and a result, so we need to remember to unwrap it. So x, y, radius, angle. So self.x and self.y, and then we need the size. So self.size, and we need the start angle, which is this, and we need the end angle, and that's all in radians. So we need some pi times 2 for the circle, and unwrap. And we need to define our pi. So const pi type was the f32, and like 3.151 whatever 4. I don't remember. Yeah, so we need the pi times 2, blah blah blah, unwrap, and field style takes 0. Oh yeah, because that's set. Set field style, and that, oh yes, because Yeah, this is where all this messing with types. So, hold on. So those are F64s, all of those. So I think let's just keep it simple, and we're going to turn those all into F64, because otherwise we will be just like messing around with this. So that means all of our random generated stuff as well. Ah, jeez. It's getting messy. So canvas width as F64. So that as well. F64. Okay. White as well. So this, so that's our canvas height as well. Yes. Okay. So yeah. We good? And this as well. We good? So respect. Yes. Okay. Oops. Cause my OBS just crashed. So not sure where I ended. Okay, so we're back in business. Okie dokie. I kinda lost my train of progress. But yeah. Pi, blah blah blah. Let's see where we are. We should be okay now. Actually. Yeah. So we are just, yeah, so we blah blah blah. Oh yeah, so we are drawing the arc and blah blah blah. We unwrapping it, and we need to actually no, we need to what is it? Fill the lack of auto completion is a little bit annoying. Yeah, okie dokie. So this is how basically our rendering is going to look like. It just boils down essentially to just drawing the particle on the screen. So here, let's just generate a bunch of those. I'm not sure what's the reasonable amount is. But basically what we need to do is just create a bunch of particles, keep them in here, and then just render them in our method in here. So particles, okay, so let particles particles, yeah. So what do we want? Let's just generate a bunch. So I don't know, 4,000, let's say. So particle new, and we need the canvas width and canvas. So canvas width and canvas height. That's our new particle, and I'm going to call collect, and canvas width is ctx dot it, and canvas height. Okay. Yeah. That should be okay as well. Oh, sorry. And that's actually the closure takes argument there. Yeah. And that expects the, okay, so okay, so we're looking good. If we just take, and there should be no, I'm just reloading it to see if there's any crashes or anything like that, because sometimes that happens as well. Okay, so what we need to do in our render method now is that we just need to iterate, and because we're going to be updating those particles, we have to itermute over it. And for each, that's our particle, for each we're going to particle update, so that will update the position values, and then it will just not update but render. That's how we called it. It's the update rendering now, so that sounds silly. It's render. But that requires our context, the rendering context. So ctx. Okay. What's our problem here? Cannot follow as mutable. Blah, blah, blah. Okay, because we need the itermute. Okay. Okay, that's good. And now this is the trickiest part, because in order to animate this, we need to request the animation frame. So request animation frame, there it is. So that's a function on the Windows object, window object in WebSys. So this, and that requires our callback function. Okay, so that's going to be a little bit tricky. So that means that we need to request our window. So like we have access to it from the WebSys, and also you re-exports that method. Yeah, I think we're just gonna take it from the WebSys. I don't know if that matters, to be honest. And that's request animation frame, and that expects a callback that we will need to provide. And that's going to be another tricky part. So like you don't want to go crazy with the recursion. So normally you would simply here just call the render method back on it. But it's not that easy to do in the WASM. So okay, let's think about this. So we need to unwrap this as well. So that takes the callback, and that's a function JS. That's object. So we need to specify the callback in here. So let's callback, and so the callback. So normally the callbacks in U is what you would simply use as a link to communicate with your other components. So in here we just need to specify the closure from WASM bingen. So we're just going to wrap our own closure that we can pass into the request animation frame. So then it's not going to take any arguments, and it's simply going to be the callback that gives that allows us to communicate with the U components. So we will need yeah, that's a problem, because we don't have access to the U context. Okay, so that's getting messy. So U context, and that's the context self. Yeah. And actually not even that, we're only going to need the U scope. Yeah, this, which is essentially the link. So if we look at the U documentation, no, just want to see the API docs here. scope has a bunch of methods, like for example send message or send callback, that allows us to send the messages within the component and then react to those events. So the send message is basically a synchronous message that you can send to the component, and the send callback is something that you would call that you would use within the event handler or something like that. So we need to scope this and pass it to the callback. Okay. So we'll need to remove this, and that's the u context dot send message, and that's essentially just going to be the message that we need to create. Okay, so let's just call it render or re-render, possibly. And actually we can do this, well, we can, but we need to box it. There. Box blah blah blah, and this needs to be in the wrap. That needs to be a box of type function mute, like this. And then this we can pass into our callback. Okay, and then that means we need to specify our messages. So not here, in here. So enum Jesus. So message, and it's going to be our render, and so that means we need to listen for that message in our update method. So we're just going to match on message, message, and when it's the message re-render, we are going to call the render message on self. That's what particle effect render. Render, and we need to pass the context to it. That should have been a reference. ctx dot link, which returns the scope object. So yeah, this has to be a reference. I'm not sure if that's the best way to do this, but I guess I just want to get stuff working, to be honest. Okay, so what's in here? Yes, because that expects the bool to be returned. this. Expected. Oh yeah, because we didn't let you know that this is what we're using. Okay. And one more error, which is here. Yeah, okay. It needs the explicit bit. One more error. Message. Why is this wrong? Expected reference JS's function. There. Found closure. Oh yes, there was something there. Function. Yeah, there was this unchecked ref where JS cast performance 0 cost unchecked cast into reference, yes. It's us. Okay, so it's actually us ref and then dot us, no, it's unchecked ref as JS cast. I think that's what it is. Oops. There. This is a mouthful as well. Explicit lifetime required in the type. Oh, that's because we're moving this into the closure. So let link equals there. Good. And one more error. It's public, yeah. Fortunately, I got this quite quickly. So nothing major was lost. Okay. So yeah, so that's compiled, and I think we should start seeing stuff. But we do not. Okay, I think that that's our problem. Hold on. Because, so request animation frame, that gives us a result. I'm not sure if this isn't some sort of handle. So that's for starters. And then another thing is the closure wrap box new. So that should put it into the heap. Okay, so I think that when this function dies, that gets dropped. So we need to keep a handle for this. So we need to keep it inside our struct. Like that. And this actually as well. So that's going to be our ctx link. Yeah. And then we need to pass that callback here. So callback, and that's essentially our closure thing. Closure din. We just need to keep the reference to it, and then that means in here we don't need this anymore. Don't need this anymore. There. Cool. Oh, and the other stuff is, oh yeah, I'm stupid as well. So probably the other thing was correct because that's on the heap with box new. Okay, we'll see. But the other thing is that we never trigger the update. So we need ctx link, and we need to send the initial message to perform the render. So then, as soon as the yeah, when you when the create method is called on the component, we send this message to trigger the rendering, and that actually compiles, which is good. Boom, and we have rendering. Okay, and nothing is happening right now because, well, there isn't much, but we see that the particles are updated and they all travel at the same speed. So if we take this, like that, it should create those all over the place, all over the canvas. Come on. There it is. Okay. So let's try to display an image now. So browser cats png. Something here. What's the size of it? 500 by 677. Okay, so we try to display the image. Jesus. Truck. Did I pass? Yeah, direct blah blah blah. So to avoid myself some typing. Okay, so what I want to do is I want to be able to fetch that image from my server and display it in here. So what we'll do is in here initially, when we do create, we will send a request to fetch that image. And I have a fetch function here that I use for fetching the post for my blog. And so I should be able to just modify this and be able to fetch an image. Image path, blah blah blah. And that should be all the same. But here, that's not going to be a text. We need like bytes or body or something like that. What is this? Response. We need Webster's response. Yeah. So we need a response, and for our post I was using the text, so which just gives me basically the promise with the text content. Okay, so we will need this or this. the API requires the following create features to be. We already have that, so I think it's blob, and that gives us promise. Okay, so in here, yeah, that's blob, which gives us promise. So that gives us image bytes, and so, but okay, we're getting ahead of ourselves. We want to be able to write the image, request animation frame, and we need to do draw image with bitmap or image element. So we need to be able to just grab the image bitmap, I guess. Draw image. There's plenty of those. Is there something for blob? What the hell? Blob. Create image, create image. Create image bitmap with blob. And that's something on the window type. Create image. Okay, that was what I was afraid of. There it is, like something like that. We just get a blob from our request here. We get image bytes. With canvas element. We need blob and window. So that means we need to, so that's our so JS future from, so here we're actually going to get the blob. So that's our blob. And that's JS value, so that means we need to do into it. So there we can use this create image bitmap with blob, and that takes a blob and gives us another promise. So let's so what do we get here? Create image bitmap with blob. So image bitmap promise, and that's, oh, in here I was using the window from view, from view. Okay, let's use it. I need to be more consistent, I guess. Where am I using and where? So create image bitmap with blob. That's what it is. Create image bitmap with blob, and that takes a blob as a reference. Create image bitmap with blob. And since this is a promise, then our image bitmap here, we need to await. Well, we need to fulfill the promise. So JS future from, and that's our image bitmap promise, and we need to await this. Await and unwrap image bitmap. So in here we should already have the image bitmap then. Bitmap, which we can return here. Oh yeah, and from websys blob and image bitmap, and this as well. Okay, no, too early. Then into, yes, unwrap. No image bitmap in the root. Okay. Okay, how are we doing? Image bitmap problems will be found. JS bitmap. Ah yeah, because we need to dig into it as well, and then unwrap as well. We'll get to the error handling someday, probably. Okay, we're looking good. blah blah blah. There. Yeah. Okay, so where are we? So that should compile, yeah. And now we should be able to fetch the image that we want to display. Okay. So if we have the method to fetch the image, that means that we should be able to run it in here upon creation of our component. And about how do we run this? Yeah, so that's what we use. So u gives us a sendFuture method that allows us to run asynchronous code from within our component. So that's what we're going to do as well here. So ctx link, and then send future, and within the future argument is basically our async code that we want to run. It's async and that's going to be a fetch image. And how did we name it? It's bgpng. And png, and the method can fail, so we need to match on OK. And that's going to be our image data. And then do something or an error. We're going to do something else. So that something and something else is going to be basically a message that we are going to create. So here. So emg fetch okay, and it's going to keep our container image bitmap, and emg fetch error and some error. It's going to be the string to the error. So that means that in here, yeah. So our message, okay, and that's going to be our image data, and our message, image message error, that's going to be our error to string. Like that. There. Wait for image arm, start here. Oh yes. yeah. So once we fetch the image, we're going to update our component. What's going on here? Mismatch types. That's because we need to await this, because that's our future, or asynchronous code, or a function. Yeah. So blah, 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 define here, not covered. Yeah. So we need to add those to our update handler. So if we have some error, message, we are going to just display it. And like I mentioned before, you removed the all the services that allowed, you know, printing to console and stuff like that. So right now you need to use glue for this, which gives you the console functionality. So like this, and just error message, because that should be string. And but when our image fetch is okay, we should have the image bytes here. And so what we're going to do then? So if we have the image bytes, and hold on, what's going on here? Yeah. So if we have our image bytes, we should be able to take the canvas, for example, and just display it. And that's what we're going to test it now. So we will need to grab the canvas, because we have the canvas reference in our struct. So we will grab the canvas, HTML element canvas, self.canvas, and we need to cast this, because you remember we have the node ref in here. So that's kind of like a generic reference to the HTML element, and if we want to extract the actual element, we have to cast this, and that can fail, so that we need to unwrap it. And once we have the canvas element, we need the canvas context that we can use for drawing, and this is the canvas rendering context 2D. And again, we need to grab the context from the canvas object. Oh Jesus, this is tiring even to articulate. Get context 2D, and then there's a bunch of unwrapping that we have to do, and that has to be into, which again can fail. But after all of that, we should have our context that should allow to draw image from bitmap, I think it was. Draw image with image bitmap. So image bitmap and the location. So cctx draw image with image bitmap. Okay. take our image bytes and the starting location, which is just the beginning of the canvas. Yeah, for some reason this macro is causing this Rust analyzer error, but it's not in fact an error. Yeah. And if we're lucky, was there an image? Yeah, there was an image, but we just redraw it straight away. We straight away redraw it when we run the re-render method. So actually, if we just comment this out, the image should stay on the screen. There it is. Whew, okay. So now, in order to copy this effect, what we need to do is just grab the pixel information about the image. So image fetch, okay. So in here, so we can do this multiple ways actually, but the problem is that if we were to grab those image bytes straight away, we need to be aware of you know, of the pixel layout depending on the image file format and stuff like that. And we would need to have like parsers for, you know, different image types and whatnot. But what we can do is we can just draw the image on the canvas and then read that image data right away, read it back from the canvas, and then we have a very you know, very nice layout of the pixel data, because the format, the pixel format from the canvas is like RGB and alpha. So that's what we can do actually. So, you know, instead of messing around and, you know, parsing those image bytes manually, we will just reuse the canvas for that. So, so image pixels. We can just read it from the canvas. So we should be able to just what was it? Get image data from the canvas, from the rendering context. Yeah. So get image data, and that gives us a result with the image data. Okay, so get image data and envelope, because that was the result. So we we want to grab the image from the entire canvas. And then again, let canvas width is cpx.props width, and the height is this. So canvas width and canvas height. Okay. And then once we have, so image fetch, okay, once we have that data, we can extract the pixel data, which is basically the brightness of each of the pixels, and depending on that pixels, depending on the brightness of the pixel, of the value of the brightness, we can control the speed of those particles that we want, you know, floating around, or, you know, descending through the canvas. Okay, so that's going to be a little bit messy. Should we maybe... No, doesn't matter. Brightness map is what we're looking for, and that's going to be a vector. And that's going to be mutable. Brightness map. Yeah. So that's that. Okay, and now what we need to do is just iterate over all of the pixels. So first first we iterate over each of the row of the pixels. Okay, we need to make a little break. Are we back online again? Okay, we are. Yeah, I had to pause the stream for a little bit. I had to pick up the child from the preschool. Came up unexpectedly. I didn't realize that you have to pick them up. Okay, anyway, where were we? Oh yeah, so what are we doing? We successfully are picking, or not picking, fetching the image from the server. We agreed on that the picture is going to be one of guts. And oh yes, so we're displaying it in the canvas, and then we grabbing it again just to save ourselves the hassle of actually messing around with different image formats and stuff like that, and raw parsing the image for pixels. So essentially we have the so what we want to do now is just get the brightness map of the pixels. So yeah, so we're going to iterate over the rows. So that's going to be from 0 to the whatever the canvas height, and then we're going to create another loop for x in 0 to canvas width, where we're going to iterate over each cell or each column. So we're iterating over the row and the column of the image. So this is going to be the whole map of the brightness values of every pixel, and in here we will need to have to store the intermediate row. Like that. So basically, once we are in the inner loop, we're going to grab each of the values for the red, green, and blue. So red is going to be the. So we're fetching it out of the image bytes. So we should be able to index it, I think, directly into the image bytes, because what we get here is the image pixels. Yeah. So let's have a look. Get image data, and we get image data, and that should have some sort of iterator on it. No. Oh, but we just can simply get the data, which is clamped vector. Vector of U8. Okay, so let buffer equals the image pixels. So that's not actually the image pixels, that's just the image data. Okay, so image data data, that's our buffer. So this in that case is the buffer, and we should be able to just index into it now as we need it. So we're going to access it by the row times 4, because we have the 4 bytes per. We have 4 bytes of information per pixel. And then width, and that plus the to index into the cell itself, and then x times 4. Red, green, so the fourth value is the alpha, so we could probably just, alpha, but we don't actually need this. Yeah, so actually I'm not gonna bother. Okie dokie, and then brightness. So here we're going to have to brightness, no, just calculate brightness, and for that we will need the red, green and blue. No co tam, dziubek? Suwasz sobie? Dobrze, tylko tata jest zajęty teraz, dobrze? Yeah, so green and blue. And that's not the width, it's the canvas width. implement this calculate brightness, and that's actually, I'm just going to steal from the internet. There's a whole bunch of you can actually steal it even from the video from Frank Laboratory. It's somewhere in the code. Actually, this is just a way to extract the brightness from the raw RGB data. Okay, and once we have this, we can stick it into the row, the row vector. Brightness. And once we have the row, and once we do this for each of the rows, we will add this to the brightness map itself. Row. So brightness row, and then once we have this, we will put this into the it's mod self. Where do we have this? Okay, so we need to stick it into our particle effect. So brightness map, and that's going to be a vector of whatever the brightness is going to be, which is probably like F64. And the reason for that is that we're going to have to calculate this using the square root function. But we will going to have to fetch the this from the JSSys library, not from the WebSys. It's from the JSSys, because that's essentially the wrapper around the math library in JavaScript. So brightness map, that's like that. So that means that in here, once we have the brightness map, we going to have to, actually it's not that, it's the, what is it, the STD, no, what's going on here, it's STD, what's it, transmute, it's not transmute, no, we will need the either swaps the value to the location without the initializing the other one if you want to swap with the default. No, we want to replace, move source into the, yeah, there it is, and we're going to replace the brightness map, which right now is just a default empty vector, with the brightness map that we have here locally. And now, because so far we were triggering the update method here, so actually we won't do this in here anymore. But what's going to happen now is that this future is going to get executed in the create method, and that will either get us into the fetch error or image fetch OK. So once the image is fetched successfully, we're going to populate that brightness map, and we're going to trigger the update rendering method from here, like that. Okay, and now we need to do this calculate brightness stuff. Calculate brightness, we need red. So actually, that's going to be get image data. What's going on here? Before as well. Okay. And we need so here JSS, we should have a mat in here. So it's here. JSS and it is 0.355. And so actually so JS JSS not SQLT. So what we want is essentially we want the red times 0. What was the function? 229 and then plus times green times 0.587 and blue times blue times 0.114. And but that's essentially, you know, those functions, they're out there. Not here, it's here. That's available if you Google it, it's there. It's something like relative brightness, or if you want more details, go into that YouTube video. In here, we're just focusing on the canvas, the websys stuff, and the Rust. And that divided by this. So that should give us this. So that means that this is going to be, okay, so get image data. Method not found. Get image data. Why is it not found? Oh, image data. Are we missing it? Bitmap. That's what it is. Okay. And yes, for indexing we need view sizes. So this and the same those bits. Oops. Are we winning? That's another problem, yes. So in here. No, those are as F64. You can either do this like this, or just do explicit cast like that. I think this is more readable, at least to me, so I'll do it as that. And here as well. Cześć, Bas.
Chciałam nalać ci i mamie wodę i chciałam, żeby skręcić wodę, będziemy
Tata wymaga, okej? Tata jest zajęty teraz. Wiesz?
Dziękuję.
Czemu taki pieszczek brudny?
Nie,
Chcesz się napić?
ale ja się nalać ci mamie jedno.
A mama już przyszła?
Nie, bo ja się odczytać. Ja to
No to dobrze, to chodź, to ci naleję do szklaneczki tutaj, przynieś szklaneczkę. A nie chodź z otwartą butelką, bo wylejesz dziubuś. Yeah, okay, so where are we? And this get image data. What's with this? Ah yeah, that expects the F64 as well. Okay. And okay, what's going on here? Ah yes, it's maybe silly. Okay, that's building. Okie dokie. Okie dokie. So I think we can just. Okay, what's going on with the image here? Let's check. Okay, so we're generating this, but now we want to make the speed of those particles dependent on the brightness of particular pixel of the image. So what is this error? Okay, that's one of the other Rust Analyzer problems. Not sure why is this happening. Okay, this doesn't matter. It's not actually a problem. Man replace, that must be used unused value. Okay. Let's go with Twitch component. Never. Okay, that's from my other things. Okay, so now we're going back here. We need to update the particle itself. Okay, so we want to update this stuff in here. Actually, it's not in our render. And what that essentially means is that we just want to change the movement depending on the brightness. Okay, so in that case, because in here we change this to float, so in order to index each of the pixels, so position X is going to be self.x as usize, because the usize is only used for indexing, and we need to do the same for y, like that. And that means that now we can get our speed equals okay, so in here we will need to pass in the brightness map. So that's our brightness map, and that's going to be a slice of vector of U8. Okay. No, not 8, it's the F64. So now that means that where is this coming from? That's an error, because this should be the brightness map, which we're going to index it with the position of first the row and then position of the column. And then we will calculate the movement. So let's say 2 minus the speed, what we just got, and then plus variable velocity. And then the self y is going to be the previous self, because we want to advance it, and plus this movement value that we've just calculated. Okay, oh yeah, because that's a float. So that should be it then. Oh, okay. So actually we just need to pass the self.brightness map, because we require it to get the speed. What's going on? Cannot borrow self as so here we borrow as mutable. Oh, okay, because we have because we only get, with Rust we can only have one exclusive borrow if that borrow is mutable. So that means, yeah, we just need to map, as we wanted to do this. Okay, let's have a look. That's building, that's looking okay. Okie-dokie. Okay, it's almost something is almost happening. So I think what we just need to do is just we just want to change the the opacity here. So from something, oops, no. And then between each of the the update and the render for the each pixel to get the speed of the particle. Oh, so that means we need to also store the speed. So F64. That. So that means in this case we just need to keep the speed. This. Like. Okay, I don't know what the story is, but under Sway, anytime I switch to the OBS to check everything is okay, it crashes, and it happened something like 3 or 4 times already on this stream. So I'm not sure what the story is. Okay, that's annoying, but that hasn't happened before. Okay. Anyway, we're almost close to the conclusion, and to be honest, I'm just trying to get this working as quickly as possible because I need to do the baby stuff in a second. Warnings. Okay, so just to recap what we have. So we have the particle, create particle with some random stuff. Oh yeah, and we don't actually want this to be random. We just want the particles to fall from the very top or from the bottom, it doesn't matter. Then we just need to increase the subtract the y value. Yeah, it doesn't matter. So this okay. So we updated depending on the brightness of the pixel, and then we render it. Oh, sorry, we render the particle. But here, this is just it has nothing to do with the image. It's just how we're rendering the white stuff. Okay, it's building. Okay, so it's just stopping on the outline of the image. So that because here we're going to make this dependent on the dependent on the speed. So that's why we put the speed into the particle struct. Did we do this? Or did I get distracted? Yeah, here. Yeah, here we update the speed. There. Sorry, it's not self speed. The speed belongs to the particle. There. It's particle. Okay. So we have our velocity. This render method, that's all fine. So the issue could be somewhere here. When grabbing the brightness data. So RGB. Oh shit, that's what it is. I didn't spot it because this stupid highlight and I just ignored this. There. Or actually no, like that. We divide by 100 the result of the square root. Ah, fuck's sake. Okie dokie. Rebuilding. There it is. Okay. So that looks a little bit better. And then again, this effect can be, you know, improved a little bit. That's not the point of it. It's just messing around with canvas and the U and the WASM stuff and whatnot. Yeah, so that's it. Probably we can velocity. This might be even a little fast. So, but anyway, all of those values can be adjusted. And that's how you do stuff in U and WASM and WASM in Rust. It was a little bit painful, I guess, to watch, Especially with those stupid crashes. It actually crashed again. What the hell? And I'm just fresh after updating the Arch just this morning. So there's probably some of that causing it. Yeah, so here we can do also cctx. You can clear the image. Clear image. No. No, that's where is it? The canvas rendering context or clear rectangle there. Blah 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 blah. This, so we can clear rect. It's going to be all the same arcs. That. And what else can we do here? Yeah, I guess this is it. There's not much stuff. Like anyone can play with those values as needs. Make this a little bit smaller as well. Here we can specify the particles as a property. Particles, and that's going to be coming from the props as well. And then we need to type it. Like that as well. So then this is particles. I think that's going to have to be, yeah, but that means then we need to specify it in here as well. Let's try 8,000. So that means we can control it from through our component parameters or arguments. What again? Yeah. There. Yeah, so there it is, more particles. So this is like kind of this, you know, a sonar effect or whatever. Almost. Yeah, so that's about it, to be honest. The rest of the stuff seems to be working as well. Closure invoked recursively or destroyed already. That's because of the page reload. Yeah, so basically what we've gone through is just, you know, operating on the HTML elements through a WebSys crate. We've done some fetching from the server. We manipulated some data, you know, from blob into image data, into image bitmap. We played with canvas a little bit. We saw how to create a component. We saw how to add it into a web page and how to call it. We saw how to handle different messages within the U component handling. We saw how to execute a future within the component. What else? Yeah, we saw how to convert the different JS objects, what's the word? Transform them from one into another. So yeah, I think I hope that it was useful to someone, to be honest. Like, this is so all over the place, so I'll probably just gonna try to assemble it into a coherent one video and just stick it on YouTube or something. So yeah, and definitely check out this dude's channel, because it's excellent if anybody is looking into play with some graphics on the web. It's Frank's Laboratory. Yeah, so take care. Hopefully see you at some other stream. I'll probably will be doing some more embedded stuff soon, because I have a little side project that I want to look after. Okay, take care, bye bye.